S1, and the S1 value, what was the S1 value? That was 0. 0 will be shifted to S2. S2. So this is the right shift register. So basically, we are getting next state as 1 0 when the present state is 0 0. And what is the condition? So we have to draw the diagram that when the present state is 0 0, that is SA equals to 0 0, and the next state is 1 0, that means this SB equals to 1 0. So what is the condition? Condition is nothing but M should be 1, that means M should be 1, and C1 and C2 will be 1 1, right? So this is the condition only when we can get the next state as 1 0 from present state 0 0. So this arrow is going down when, that means SA will be gone to the SB, that means 0 0 will be going to the SB, which is 1 0. The condition is when MJ equals to 1 and C1 and C2 is 1 1. Okay. Again, I'm considering the present state as 0 1, so this is 0 1. Okay. So as well as message is considered as both value 0 and 1. So first of all 0, I'm considering 0. So when I'm considering 0 as a message input, so this is S1 and S2. So we are getting C1J as M XOR with S2. So 0 1 is 1 and C2 is basically the XOR of 3 elements, that means 0 0 0 and 0 1 is 1. So we are getting both value C1 C2 as 1 1. So what will be the next step? Next step, when we are initializing again the MJ as a new value, then the previous value, that is 0, the 0 will be shifted right to the S1, and S1 value will be shifted right to the S2. So we are getting 0 0. So how to represent it in a diagram form? That means what is the condition when the present state 0 1 will be shifted to next state 0 0. That means 0 1. What was 0 1? That was 0 1. Okay. So when I'm assuming the present state as 0 1, so what is the condition that this state will be shifted to 0 0 again? That means this arrow. So what is the condition? Condition is that the message input should be 0 and the C1 C2 will be 1 1. Okay, as we are getting this, that means the message is 0 and C1 C2 is 1 1, and then only the present state 0 1, that means this 0 1 will be shifted to the next state, which is 0 0. So in this way, when again present state is 0 1 and next state we are getting 1 0, that means this 1 0. So what is the condition? You can see our arrow is going from SC to SB. Okay, and what is the condition? The message input is 1 1 and C1 C2 is 0 0. So this is the condition by which we can convert this S2, that means this state, that means this 0 1, the present state, to the 1 0. So you can see from the table that when I'm using M as 1 and present state is 0 0 1, so C1 is basically M XOR with this 1, that means this 1 XOR with 1, that means 0, and again C2 is 1 XOR with 1 and XOR with 0, which is 0. Okay. So C1, C2, we are getting 0. So that's why when SC, the present state is 0 1, the next state is we are getting 1 0. Why 1 0? Because when I'm again feeding M as new value, this 1 is shifted to this and this 0 is shifted to S2. So the next value is basically 1 0. So what is the condition? That means 0 1 is the present state and this is 1 0 is the next state, and the condition is M, where the input should be 1 and the C1 and C2 will be 0. Okay. Same as I'm considering again two values like 1 0 and 1 0. So I'm considering this 1 0 as a present state. When I'm considering this 1 0 as a present state, what is the transitions? What is the transitions happening? So when this M, the message input is 0, okay. So what is the value of C1 and what is the value of C2? So C1 is basically 0 XOR with 0. M XOR with S2. So 0, 0, 0 and 0, 0, 0, 0, 1 is 1. XOR of 3 elements will generate the CT. Okay. And what is the next state? Next state, when I'm initializing again message as a new value, so then the previous bit present to the message, so that will be shifted right to the S1, which is 0, and the value present at the S1 in the past, so that 1 will be shifted right to the S2. So we are getting next value as 0, 1. So now similarly, this is the present state, which is 1, 0, and the next state we are getting 0, 1, right? So what is the condition? That when this 1, 0, the present state will be converted to 0, 1. Okay. So we are just assuming that uh, this is 1, 0. So this is the present state, and our next state is 0. So that you can see that one arrow is going from SB to SC. Okay. And what is the condition? When the message bit is 0, that means this 0, and C1 and C2 is 0, 1. So C1 and C2 is 0. So in this way, you can draw for this transition that when 1, 0, let me just erase it. Okay. So when the present state 1, 0 is converting to the 1, 1. So what is the condition? The condition is basically when I'm considering the present state as 1, 0, that means this 1, 0, and I'm initializing this message bit as 1. So we are getting C1, C2 as 1, 0, and the next state. What will be the next state? Easy, because when I will feed this encoder with the new message bit value, then this 1 will be shifted to this S1. So 1 will be shifted to S1, and this S1 value 1 will be shifted to right to S2. Okay, so we are getting next value as 1, 1. So this is the condition that when 1, 0 is present state and 1, 1 is the next state, the condition is that message bit will be 1 and C1 and C2 will be 1, 0. Okay. So in this way, you can draw this diagram, which is called state diagram, and for each condition, that means for each possible present state, that means 0, 0, 0, 0, 0, 1, 1, 0, 1, that is SA, SP, SC, SD, this all possible combination of states. These are basically all possible combination of the states. So you have to just draw it first, then you have to make this table, and you have to compute one C1 and C2, and it will represent this table like this diagram. Like when SA is converting to SB, that means present state 0, 0 is going to next state 1, 0. Then this is the condition. The message should be 1 and C1, C2 will be generated as 1, 1. When 0, 0 is a self loop, that means 0, 0 is the present state and 0, 0 is the next state. Then this is the condition. The message should be 0 and C1, C2 will be 0, 0. So in this way, you have to make the table, you have to make the diagram for all 4 combination 0, 0, 0, 1 and 1, 0, 1, 1. And you can see from this book that here it is. Here it is. So let me just erase it. So many sketches are there. So I'm just showing you because it's not possible to erase all sketches. Okay. All the lines. So many lines are there. Okay. So I'm just showing you the table where they have considered all the possible values. You can see from this table.